So here we are, we're gonna let u equal to sine x. So du would equal exactly what here? Cosine x dx, good. So what are we left with here? Oh, we've got 1 over 1 plus u squared du. Well, that's embarrassingly too easy. Y'all ought to be mad if I give you a question like that on the test because I've insulted your intelligence. So, but what is this?
The antiderivative of it?
Yeah.
The natural log
All right.
oh wait, no.
So no. I want you to say, you said natural log. So let's look. So let's let x equal, not x, we start off with x. Let's let z equal to 1 plus u squared. So dz would be 2z. Using things other than u mess me up. All right, so you'd have a 2u du here, right? So in natural log problems, this denominator needs to be a constant. And there we've got a linear term, so that doesn't work. But again, I like seeing failures because that allows us to see what doesn't work, and we're going to try something different. No. All right. So again, what is the antiderivative of this?
Inverse tangent of u plus u.
So it's the tangent inverse of u plus a constant, which would be the tangent inverse of the sine of x. Let's see. That one's all right, wasn't it?
How did we get that? I don't want to hear from you. Ask us that.
Also explain, but never mind.
How did it get what?
The tangent.
All right, because this is in the form of 1 over 1 plus u squared du. And remember, the derivative of the tangent inverse of u is this.
Oh, yeah. I got you.
All right. What's your question? No, he's not. He's making me look good as a teacher. And that's what counts.
That's what your grade depends on in this.
Yeah. How good I look as a teacher. All right, so can I erase this? Okay. That one may have been too easy. I won't do that to y'all again. All right, again, if you let u equal what's under the radical here, you would end up with a chain rule, so you'd have a 2 sine x cosine x in there. And we only have a sine x dx in the numerator, so that's going to be a difference maker there. So what do I do from here?
Divide by 4.
Yeah, pull out this because this needs to be a 1. All right, now, what would happen to my cosine squared x when...
X over 2.
Say that again?
Cosine of x over 2 all squared.
we still good? All right, so square root of 4 is 2. So I've got 1/2 of sine x over the square root of 1 minus cosine x over 2 squared dx. All right, so what happens next here?
U is equal to cosine x over 2.
I'm gonna write it as 1/2 cosine x. That may be easier for us to see as far as doing the derivative here. So what is the derivative of 1/2 cosine x?
Negative 1/2 sine.
Dx. So negative 2 du equals sine x dx. So pull the negative 2 out front, so we've got the negative of 1 over the square root of 1 minus u squared du. What's that in the form of?
Inverse sine.
Inverse sine. So it's the negative of the sine inverse of u d, no, plus c. So it's the negative of the sine inverse of,
Cosine x over 2. Or 1/2 cosine x.
or we put it like that. That looks more smarter. And again, if you wanted to call that the cosine, negative sine inverse be the cosine, so you'd have the cosine inverse of that. Any question there? Okay.
All the way back at the beginning.
Okay.
Why is it when you divide cosine squared x by 4, it's cosine x over 2?
Okay. It's okay. Are you okay with this?
Yeah.
Okay. Well, the cosine squared x, I've got a perfect square over a perfect square. So that's where I get that from. Cosine squared x is cosine of x squared, right? 4 is 2 squared. Remember, I'm needing it in this form. I need it in this form of 1 minus u squared. So I've got to get a u, and that u I get has to be squared. So I have to figure out what is it I square to get this.
It's like factoring out an exponent instead of over 4.
Did that help? Okay, good, thank you. Once again, he's making me look good as a teacher. You don't have to breathe that quick. All right, so, I know. Let me give y'all one to try on your own. Hopefully this is a little easier. And I will post the answer in the comment section underneath the video.
Pin comment.